Okay, so this is the last part for section 4.1, and we're going to start doing an example where we're talking about compound interest. And this is an example where you can choose between two investments, and we'll talk about different interest rates and different compounding choices. So here I have to decide to invest. I decide to invest $8,000 for 6 years, and a choice between two accounts. So I have $8,000 for 6 years. And I have two choices. I have one that pays 7% per year, compounded monthly. And then the other choice is a lower interest rate at 6.85%, compounded continuously. So I'm going to use A equals P1 plus R over N to the NT because it's compound monthly. I'm going to go ahead and put in the values that I know. And so now A equals, trying to figure out the cumulative amount, principal investing $8,000. 1 plus the interest rate is 7% per year. I want the decimal, it's going to be 0.07. You're going to take the 7%, and move that decimal place, which is right here, 2 places to the left. And compound monthly, when I compound monthly, that means N is going to equal 12 times a year. So 12 down here. And then we have 12 times 6, because it's going to be invested for 6 years. There's my N, and T is for 6 years. I'm going to replace 12 times 6 with 72. I'm going to type a calculator, it's a little easier to type that in, so 72. So now, if you have the TI-30X2S, you're going to type this entire thing in your calculator. If you have a different calculator, you may have to separate it and do this, and then times 8,000. But either way, whatever calculator you have, go ahead and type it in, as long as it's not a graphing calculator. You should get the same answer I do, and if you don't, then you're going to need to make sure that you get with me or go through your manual and figure out how to work it. And again, I'm going to raise it to 72 pounds and use that little exponent button. The little button looks like this for my calculator. Okay, so my answer for the first one, I get a cumulative amount of approximately $12,106.84. So you invested $8,000 for 6 years. So 6 years later, your account's going to have over $12,000. It's a good investment. Make over $4,000 in 6 years. Okay, and so let's go ahead and do compound continuously. What form are we going to use there? We're going to use the A equals PERT, P times E to the RT. So A is going to equal, again, A stands for the cumulative amount. That's going to be the amount that's in your account after all that time. And I'm going to invest $8,000. E to the rate, this rate is going to be smaller, it's going to be 0.0685 times 6, because it's going to be for 6 years. 0.0685 times 6 is the same thing as 0.411. Okay. So now accumulated amount is going to equal 8,000 times e to the 0.411. Again, use your calculator and figure out how to type in your calculator. I get $12,066.60. So if you had choice between those two accounts, after 6 years, it looks like this account can make a little bit more, almost $100 more than this account here. So the better investment is the account paying for 7% per year, compounded monthly. So again, I told you a second ago, or in the last part, is that compound continuously. Again, it's compounding every 20th of a second, but it really didn't make any more money. In fact, it made less money than when we compound monthly. Generally, they tend to take the interest rate smaller just to compensate for every 20th second. Okay? So again, on your own, I want you to go ahead and do the next problem, and you're going to choose between two accounts. Well, actually, you're going to show the balance after 5 years in two different accounts. One's going to compound quarterly, and one's going to do continuous compounding. And you're investing $10,000. The interest rate's the same. Okay? So do it on your own. Go ahead and pause the video, and then check your answer. Okay, so I did this one on your own, and hopefully you did it too, and check your answers. For part A, I wanted to see how much was accumulated after 5 years when compounded quarterly. I got $14,859.47. I went to the nearest cent. And then continuous compounding, I got $14,980.25. It didn't ask you for which one's the better investment, but it looked like the continuous compounding for investment, because notice how the interest rate was the same for both of them. Okay, that's the end of 4.1, so you can go ahead and if you have any questions, make sure you email me, and we'll go ahead and in the next section we'll talk about logarithmic functions.